Alright, so I think I'm recording. Let's take a look at this last problem, problem 30. They give us two functions f and g, and they ask us, are these functions inverses of each other? So we need to find the composition of f composed with g, but also g composed with f. If it's true that we get this guy to reduce to x and this guy to reduce to x, then we will conclude that they are inverses to each other. If even one of them doesn't equal x, then they will not be inverses of each other. So let's find fog first. If we take f composed with g, we know g to be this 1 minus x over x. Alright, so here maybe I should tell people what I'm doing. I'm finding the expression for g composed with f. Oops. Alright, so let's plug this into f. Well, what does f do to the input? F always creates a fraction. 1 is always in the numerator. And you always have the input plus 1 in the denominator. Well, this time, the input itself is a fraction. It's this ugly mess that goes here. So we need a way to simplify this complex fraction. We have a fraction within a fraction. In algebra, a common technique is to multiply by the number 1. But I'm going to write 1 in such a way that it clears my fractions here. I have an x in the denominator. I'm going to multiply this by x and have x here. So really I'm just taking my expression and multiplying it by the number 1. The resulting expression is going to look different, but it's going to be equivalent to the original complex fraction. When I multiply fractions, it's very easy. I just multiply the numerators together, so I go straight across. 1 times x is x. In the denominator here, this x gets multiplied, it multiplies both of these terms. When this x multiplies the first term, you have x divided by x, which cancels, so we just get 1 minus x. When you take x and multiply it by the second term, you get plus x. Well, now it's much easier to simplify, and we can see that we are going to get x. We have an x in the numerator. The plus x and minus x cancel, and x divided by 1, well, that's just x. Alright, so it's true that g composed with f is equal to x. Now I suspect that this other one will also equal x, and let's look and see if it does. This time, however, we want to take g and plug it into f. So g itself is this fraction. And what does f do to the input? Well, wait a minute, I'm doing the same thing. So did I mislabeled this. This guy, I apologize, was not g composed with f, but f composed with g, right? F composed with g, because it was g of x that was 1 minus x over x. So over here, I need to take the function f and plug it into g. Sorry about that. F is this 1 over x plus 1. So what does g always do to the input? Well, g always creates a fraction where the numerator is 1 minus the input, no matter what that input is, and the denominator is always the input. So I can see over here that my input, 1 over 1 plus x, is going to go here where there was an x, and also down here. So I have this 1 over x plus 1, and I have 1 over x plus 1. So again, this is a complex fraction, a fraction within a fraction. And we're going to take the same approach. We're going to multiply this by the number 1. And to multiply by the number 1, we look to the denominator here and see that it's x plus 1. So I'm going to have x plus 1 over x plus 1. When I take this x plus 1 and multiply it times this denominator, because see, for fractions, you multiply the numerators together, you multiply the denominators together, I can see that that x plus 1 and that x plus 1 divide to 1. I can see that I'm going to have a 1 in my denominator. Now, I need to take this x plus 1 and distribute it to both terms. When I take x plus 1 and multiply it by 1, I get the x plus 1. When I take x plus 1 and I multiply it by the second term, the x plus 1's cancel just as they did before, and I just have minus 1. So the plus 1 and minus 1 cancels, and x divided by 1 is x. So now, since both of these compositions are x, we can say, yes, these two functions are inverses. Now, to get full credit, you have to show your steps. You can't just mysteriously skip a bunch of steps and write it equal to x and mysteriously here, and the steps have to be correct. You know, it has to be logical. One equation has to follow to the next. So notice I had that. I had my equations in here. I illustrated that I multiplied by 1. You must do the same. So I hope that helps.